Welcome to another lesson of Math 0420 Introductory Algebra. In this video, we will be discussing section 6.4, Factoring Special Forms. In this section, we will factor the difference of two squares, we will factor perfect square trinomials, definition. The difference of two squares. If A and B are real numbers, variables, or algebraic expressions, then A squared minus B squared can be rewritten in a factored form as A plus B times A minus B. Okay, let's try an example of that. Example 1. We want to factor x squared minus 81. Now, do you agree that that is A squared, something squared, minus B squared? Are there two squares there? Well, x squared can be rewritten as x, quantity squared, and 81 can be rewritten as 9 squared. Okay, so what we can do is we can rewrite that as x plus 9, x minus 9. Okay, let's do another. 100x squared minus 9y squared. Is 100x squared a square? Yes, it is. It is 10x quantity squared. And negative 9y is negative 3y quantity squared. 3 squared is 9, and y squared is y squared. So we can rewrite this as 10x plus 3y. Example 2, we want to factor. For part A, 36x squared minus 25. Well, 36x squared can be rewritten as 6 times x quantity squared, and 25 can be rewritten as 5 quantity squared, which means using the difference of squares, we can rewrite this as 6x plus 5 times 6x minus 5. Okay, let's do one more. If we have 18x cubed minus 2x, can we write this as a difference of squares? Well, something cubed is not necessarily squared, but we could try doing a GCF. Both of these terms have a 2x as a factor, so we can rewrite that as 2x times 9x squared minus 1. And hopefully that one looks a little bit more like a difference of squares to you. So that's 2x times, well, we have a 3x. 3x times 3x is 9x squared minus 1 squared. Oops, we'll use a parenthesis there. So we can rewrite that as 2x times 3x minus 1, 3x plus 1. And it doesn't matter which order you choose for these factors because of the commutative property. Factoring perfect square trinomials. Let's start with the definition. Let's let A and B be real numbers, variables, or algebraic expressions. Then we get two different equations here. Then a squared plus 2 times a times b plus b squared is equal to a plus b, quantity squared, and a squared minus 2ab plus b squared is equal to a minus b quantity squared. Okay, let's do an example. Example 3. We want to factor x squared plus 14x plus 49. And what we want to try and find is that something is being squared here, something is being squared here, and that their product of their coefficients of the things being squared, so in this case would be x, this case would be 7. If you multiply that by 2, then we should be able to get something of this form. So let's rewrite that as x squared plus 2 times something, 2 times x, that's being squared, times 7, that's what's being squared to get 49, plus 7 squared. Okay, that looks like 2 times a times b, so we can rewrite that as x plus 7 quantity squared. Okay, let's try another. Example 4. We want to factor 16x squared minus 56x plus 49. First one being squared is 4x. This is 7 squared again. So hopefully we can rewrite this in terms of a difference of a perfect square. So we can rewrite 16x squared as 4x quantity squared minus 2 times 4x times 7, that's what's being squared in the other term, plus 7 quantity squared. And so since we can do it that way, we can write it in that form. We can rewrite the whole thing as 4x minus 7 quantity squared. Factoring the sum and difference of two cubes. Let's start with a definition. So we want to let a and b be real numbers, variables, or algebraic expressions. Then we get the sum of two cubes is a cubed plus b cubed, and that can be rewritten as a plus b times a squared minus ab plus b squared, and we can get the difference of two cubes and that is a cubed minus b cubed, which simplifies to a minus b times the quantity a squared plus ab plus b squared. Okay, and when we are talking about factoring a sum or difference of two cubes, what you want to remember is SOAP. Same, opposite, always positive. And this is true for all of them. So the same, that means that the first signs are the same, whether it's a difference or a sum. Opposite, you could also look at these to see that they're opposite. If you start with an a minus b, you have the same, and then you have the opposite. And then the last term, no matter what, is always. Example 5. We want to factor x cubed plus 27. So first we want to figure out, is this a sum or difference of cubes? Well, it's a sum of something, but x cubed plus 3 cubed. 3 cubed is 27. So we can rewrite that as a sum of cubes. Well, let's remember the formula for that. That's a cubed plus b cubed can be rewritten as a plus b times a squared minus ab plus b squared. Okay, so we can plug in our a and b, which are x and 3. So we get x plus 3, x squared minus 3 times x plus b squared, which is 3 squared, or 9. We want to check to see in this squared trinomial, this trinomial here, that to see whether it factors. We would be looking for two factors that have the same sign, that whose difference was negative. We can't have that happen in this case. There are no factors that work, so this cannot be factored further. You do need to be sure to check the factor. Example 6, we want to factor 1 minus y cubed. Is this a difference of cubes? Well, we can rewrite this as 1 cubed minus y quantity cubed. So it is a difference of cubes. Let's remember the formula for that. That's a cubed minus b cubed. And that's going to have the same sign, which is a minus b, times a squared, opposite sign, plus ab, plus b cubed. That one's always, b squared is always positive. So we plug it in. We get 1 minus y, 1 squared plus y times 1 plus y squared. And so we can rewrite that as 1 minus y. 1 squared is just 1, so we have y squared plus y plus 1. So this is our final answer, and that is the conclusion of section 6.4, Factoring Special Forms.